guys. Good morning, learners. My name is Mr. Paul Chilola once again. Welcome to this session in which we are going to look at one of the mock papers for this year 2025. This paper was written in Southeast Education Division, which in short is called SEED. All right. So this is their mock. In case you are wondering which schools make up Southeast Education Division, these are mainly schools such as those found in Zomba Rural, Zomba Urban, Balaka District, Mangochi District, and Machinga. So schools that are found in these places make up Southeast Education Division. So this is the mock written in those schools. So you think of schools like Box 2, Zomba Catholic Secondary School, St. Mary's, and the other big schools. So they wrote this paper. Physics, paper 1. Much as individual schools might have their own mock exams, but this one was written at divisional level. All right. So there's need for you to write school name. Let's say school name. I'll just indicate black slides. Don't forget to write your school name, the name of your school. Also indicate the examination number. Examination number, your number usually starts with M for MSCE. And then the center number, let's say the center number is 123. And then your own number, call it 001 if your number is 1. Right? So that is all you need to fill in on the front page there. Okay, then you read instructions, follows the instructions. The instructions are saying, first of all, check that you have the correct paper. So this happens to be paper 1 of physics. Check that is paper 1. And the paper 1 is the theory paper, which carries a total of 100 marks. All right, and take note, your exam was to run for 2 hours. This is also what you're going to have in your MSc exams. The paper 1 physics will have 100 marks altogether, and it will run for 2 hours. Make sure you are familiar with the structure of this paper before you write your MSc exams. Know the structure of the paper so that you prepare very sufficiently. Okay, so read instructions. The paper has 10 printed pages. These are things which you need to check before you start writing. And also they are saying you have to indicate your number, write your number before beginning to write. Okay. So the space for the examination number there, always check. And also the paper has 2 sections. You're going to check physically. You need to check that the paper has 2 sections. So these are just things that you needed to check the preliminary. As you're considering or checking the structure of this paper usually has 13 questions. and you are supposed to answer all 13 questions, all the 13 questions, without skipping any one of them. All right, and you are allowed to use a calculator, electronic calculator. All right, and as you write, you'll notice that the maximum number of marks for each answer is indicated against each question. When you finish writing, you're supposed to tick. So tick against the number of the question you have answered. So when it comes to ticking, please tick here in these boxes. These boxes. This is where you have to tick. You have to tick. The ticking is an indication that you answered that question. If you didn't answer that question, there's no need for you to tick. Just leave it blank. Just leave it blank. Please don't tick here. Don't tick in this part. Alright, this part is for the examiners, those who are going to mark your paper. So let's suppose I'm marking your paper. I'm marking question number 2, which has 5 marks. I'll indicate 5 marks here. 5 marks. Alright. While this part here is for the senior examiners. Suppose that your paper, the paper I marked has been remarked by a senior examiner. So a senior examiner will also indicate their mark there, and the comparison between the two will be made. All right, this is just done for quality consistency sake, for consistency in marking. So once again, don't mark here. This is, don't tick here. This is not for you to tick. Right, so that's basically what we have on the front page. Okay, now, without further ado, let us look at the questions which our friends in... by the way, remember to write your number, examination number, on all pages at the top here. There is a space for you to indicate your number there and your school name. Remember that this paper is written by many schools, so you need to indicate the school where you are. But for money paper, there's no space for name of school. Just examination number is fine. All right, so without much talking, let us go through the questions and look at the expected answers, if we can. So we are trying to read the mind of the examiners who formed this paper. Okay. So question number 1 is saying, by the way, check that questions, this is section A, which carries 70 marks, and you're supposed to answer all questions in this section. All right, so question number 1, a student conducted an experiment to find out the effect of temperature on the solubility of salt. In this experiment, give independent variable and a dependent variable, 1 mark for each. So all you have to recall is what is an independent variable and what is a dependent variable. Remember that an independent variable is just the factor which you change deliberately in an experiment, and you observe its effect on the other. So the factor which is changed deliberately so that its effect can be observed on another factor is called the independent variable. So in this case, the variable being changed is the temperature. Right, so we change temperature and observe how it affects its solubility. Therefore, in this case, the independent variable is the temperature. So you write temperature there. Right. So temperature is the independent variable. So temperature is deliberately changed so that its effect on its solubility can be observed. All right. So the solubility of salt is dependent variable. What we mean here is that the solubility of the salt will depend on the temperature of the solvent. Okay? Of course, theoretically, to say that the higher the temperature, the higher will be the solubility. Or as temperature increases, more salt is dissolved. That's what we are saying. So temperature is changed in order to observe its effect on the solubility. Solubility is just the amount of salt dissolved in a given volume of solvent at a specific temperature. Right. So that's all you had to do there. So if you got these two right, it means you have 2 marks for that first part. All right, let's go to number 2. Question number 2 is saying there's a diagram here, the diagram showing measuring instrument. Use it to answer the questions that follow. All right, so this obviously seems to be an ammeter. It's an ammeter. Remember what an ammeter does? It measures electric current. An ammeter measures electric current, okay? All right, so you are asked, part A, you are asked to state 2 types of errors. Types of errors associated with this instrument. Okay, so this is a measuring instrument which has a scale on it. Okay, take note that it has a scale that ranges from 0 to 50 in the positive direction. By that we mean this is the starting point. So the pointer is going to move this way, as shown, starting from 0. And also sometimes maybe it can go down below, but that is decided by the way it is connected in a circuit, which is an anomaly. It's supposed to read in the positive. The pointer is supposed to deflect to the right from 0, from here. Okay, if it goes this side, it means that it's not properly connected, and you'll need to make some adjustments so that it is properly connected. Okay, so state any 2 types of errors associated with the instrument shown. All right, so remember this is an instrument, a measure for measurement. So already you can appreciate that an instrument like this one is associated with 0 error. 0 error. Or you can say systematic error. A 0 error is not a systematic error, as some think. Okay, a systematic error usually is an error that is associated with an instrument and is consistent in all measurements. So every time you use the ammeter, if it has a particular error, that error always occurs. Okay, so since the question has not specified, has not limited you to the types of errors that are associated with instrument. Okay, so you can say zero error, systematic error. Yeah, basically these two. The types of errors which are associated with the instruments, measuring instruments. All right. Moving on, number 2B, you are asked to convert the reading shown in figure. Okay, so you need to check the reading here. What's the reading? All right, so let's zoom in to see the reading there. So in order to identify the reading, you need to know the least count of this instrument. What is the least count of this instrument? All right. So if you check from 0 to 20, here, there are 20 divisions. I mean, there are 10 divisions. From 0 to 20, there are 20 divisions. 10 divisions. So 20, from 0 to 20, there are 10 divisions. That means each division is a 2 microampere. Okay? So, reading from the instruments, this is 20, over here is 20, that means over here is the 30. So this is 30, and then the pointer is on the next division after 30, that means it's 32. 32, because remember that each division is 2 microamperes, so this should be 32 over here. That's 32. Okay, so you are asked to convert 32 microamperes. These are microamperes. I'm sure you know what a micro is. So we are saying we are changing 32 microamperes to amperes. So we need to find this, convert this to amperes. So what you need to remember is that 1 microampere is the same as 10 to the power minus 6. Therefore, 32 microamperes is the same as 32 times 10 to the power minus 6 amperes. So the minus 60 here is a micro. This thing here is called a micro. So you have replaced the micro with 10 to the power minus 6. You can leave it like this if you want, like that, because you have, by the way, you have expressed it in what? In terms, we have changed the micro into the power of 10. All right. Or if you want, you can write this as 3.2 times 10 to the power 1 to the power 1 because I've shifted our decimal there, the power 1 multiplied by 10 to the power minus 60. And then you simplify. So this eventually is going to give you 3.2 times 10 to the power 1 minus 60, which is 3.2 times 10 to the power minus 5 ampere. It's all up to you, but I don't see why you should be penalized for just stopping up to here, because after all, the question is just let's check how many marks it is worth. It's just 1 mark after all. So for me, I would not really be troubled if I write this as a if I just write this in one statement. So I know 32. So 32 is the reading there. Yeah. Then you multiply this by 10 to the power minus 60. And then write ampere there. That's 1 mark. Yeah. So you shouldn't be penalized for just writing this step like this in one statement. Yeah, so that's what you should have done and get you 1 mark. Okay. All right, so that's what we are doing. Remember, we are just looking at the expected answers for this paper, which is written by our friends who are in schools in Zomba Rural, Zomba Urban, Balaka, Mangochi, and Machinga. Schools that are there wrote this paper. In my opinion, I think this is a very good paper. Yeah, it's a very good paper. Okay. Question number 3, moving forward. Question number 3. Figure 2 shows effect of a magnetic field on nuclear radiation. Use it to answer the questions that follow. All right, so we have here the source of radiation. So this could be something, maybe uranium or any radioactive substance. So remember, a source can emit 3 types of radiations. Namely, it can emit alpha radiations. These are types of radiations, which you must know, including their characteristics. Alpha, it can be beta, it can be gamma. 3 types of radiations. You need to know these, including their properties. All right, so we are saying these can be emitted at the same time. Good enough. We have been told that this one is gamma. Therefore, we need to identify R and S. R and Q. All right, so let's look at the question which is being asked. Identify the type of radiation Q, R, and T. Q, R, and T. Unfortunately, I can only see Q and R. I think T was to be this gamma, which they have already named. Yeah. Okay. So, in this case, we are going to identify Q and R only. Even here on the space, we are only given Q and R to identify. Okay. Yeah. So let's go back to the diagram. What could be Q? Okay. What could be Q? Remember, the North Pole, if you to draw few lines always originate from North Pole to South Pole. This you needed to know from magnetism. Okay. And this behavior is similar to charges, positive charge and negative charge. When you're looking at an electric field and compared it to a magnetic field, field lines in an electric field also originate from North Pole, positive charge to negative charge. Okay, so in this case, the North Pole behaves as if it's a positive charge because the field lines are originating from it to the South Pole. Just like field lines in an electric field originate from the positive terminal, from positive charge to negative charge. So in this case, R therefore should be a beta. So beta, or some say beta. Beta particle is deflected to the North Pole. And also recall that a beta particle has no mass, okay, and is negatively charged. Okay, and because it has no mass, it is going to deflect more. You can see here there is so much bending. It deflects more than Q. Okay, so suspectedly, R must be a beta particle. A beta particle, because it has deflected more than Q. And obviously Q needs to be an alpha. Remember, an alpha has a mass of 4 and a charge of 2. So because of its high mass, it deflects less. Okay? Deflects less. Alright, like I said, the South Pole behaves as if it's negative. Remember, alpha is positively charged. As we always say, positive goes to negative. Alright, so go back to the space there where you have to indicate to write something. Identify. R is beta. We have mentioned that R is beta. You have to mention beta in words. Identify the type of radiation. So you say beta radiation or beta particle. It's a particle also. Q, therefore, is alpha. Please revisit the properties of these types of radiation. When answering, make sure you give names rather than symbols. So instead of saying Q is alpha, don't just write this, no. Or this for beta, no. You have to indicate the actual names. All right, I hope so far so good. We are moving together very well. My name once again is Mr. Chilola, your physics teacher on the Black Slides. Please invite your friends to join us so that they can also benefit from this. Remember to subscribe to the channel so that you should be the first ones to receive a notification when a video is uploaded. All right. Then a further question, it says, give any two properties of radiation Q. So just say the Q is alpha, so you need to mention the properties of alpha. In other words, if you messed up here on names, then it means you'll also miss this question here. Okay, so this is a dependent question. B depends on A, what you said on A. So what are the properties of alpha? Remember, alpha is doubly positively charged. So you can say it's positive. Alpha is positive. It's positive. Alpha is positive. It's highly ionizing. More ionizing. You can say it's more ionizing. More ionizing. You can say that. You can also mention properties like less penetrating compared to the others. Less penetrating. So these are the properties that the examiners are looking for. Or you can also add the high mass compared to the others. High mass. The mass is due to the fact that it has 2 protons and 2 neutrons. Right? There are many others that you can list down. Okay, so let me just write this properly in case you were copying. So we are saying is that is suspected to be alpha. It's more ionizing, you can say that, ionizing than R, where R is a beta. Okay. It's heavier or has more mass, you can say more mass than beta. You can say many things. You can say it's less penetrating. Remember that alpha can easily be blocked by paper. So that's a property called less penetrating. It penetrates less compared to less penetrative compared to the others. All right? They're only asking you to write Na2, so don't write too much. Don't write too many points, just enough. But I would urge you to know all of them so that you can write down Na2. Okay? Not forgetting the fact that it has the least speed compared to gamma and beta. Right. Let's see. They're asking us for use of radioactive substances or use of radiation. This question is basically asking you for use of radiation. Yeah. So where do we use them? They are used as tracers. Remember, to monitor the absorption of minerals by plants. They are used in the treatment of cancer. Treatment of cancer, which is called the radiotherapy. They are also used for sterilization of equipment, sterilization, to sterilize equipment like medical equipment, to kill germs. Remember, sterilization is killing germs using radiation. And the other uses, they're just asking you for one of for determination of thickness of metals, determination of thickness of paper, all those uses. However, if you're not monitored, they are dangerous. They are like fire. Remember, fire is both good and bad. We say that fire is a good servant when it's under control, but it becomes a bad master when it is out of control. Yes. So use of these can be both good and bad. So one use there, when exposed to the radiations, these radiations can cause cancer, causes cancer, say that. In some small dosages, it can cause headache, it can cause nausea, that's a feeling to vomit, it can cause blindness, it can cause many things, mutations. I just want you to write down any one. Don't write all these, the examiners will not mark the rest. They're just interested in one. Right, so that was question number 3. Let's move on to question number 4. Question number 4 is talking about figure 3, showing a diagram for hydraulic machine with piston 1 and 2. Right, so let's look at this. So this setup is called the hydraulic machine or hydraulic system, if you like. So it has a hydraulic system has 2 pistons, what is called a master piston and a cylinder, a slave. Okay. So usually one piston has a smaller area than the other. By area, I mean this portion here compared to this one. So this area is smaller, this area is bigger. Okay. All right, so use it to answer the questions that follow. So remember that hydraulic systems use the liquid pressure. Okay, it uses liquid pressure, or the Pascal's principle. Pascal's principle is about liquid pressure. It says that for an enclosed liquid, pressure at one point is applied at one point is equal to pressure at all points within the liquid. Okay, you can check the actual version of it, but suffice to say, that the pressure exerted here is the same as the pressure anywhere within the enclosure, the system. And we are going to use that fact to carry out a number of calculations. All right. So, question part A is saying, calculate the pressure exerted at point A. Pressure at point A, right here. So you're going to use the formula for pressure. Remember, pressure is force exerted divided by area. As simple as that. All you have to do is first write down the formula. By writing down the formula, you have 1 mark to yourself, and then you substitute. So the force is given to us as 200 newtons, and the area is 0.1. So when you divide 200 by 0.1, you should be able to get 2,000. So the result is 2,000. Remember, the units of pressure are pascals, so write PL. All right, that's it. So that's what you're supposed to do, and you get yourself 2 marks there. All right, and then you're using the same diagram or figure. Calculate the force exerted on B force. So here we are asked to calculate force. So we are going to use the fact that pressure distributed in a liquid is the same at all points. That's Pascal's principle. Okay, so let's suppose that the force exerted here is the F1, and the force which is exerted on the load upwards is F2. So using Pascal's principle, the pressure at the A is equal to pressure at B. That's what you do. That's what you state in the first place. So, but what is pressure at A? Is 200. You can use the equations, the symbols that we have. Okay. So we are saying pressure at A is F1 divided by A1. A1 is the area there. Okay, or just the A, because we are told the points A and B. The area at the, sorry, let me start all over. So the pressure at the A is F1, or F at the A, divided by area. Okay, let's just call this area at the A as well. And then this is equal to, the pressures are the same, so this will be equal to force at B divided by area at B. Yeah, this looks better. Okay, so you have 1 mark for saying that. Then substitute. So we already know what this is. We calculated this is 2,000. So this is 2,000 newtons. Then we have F at B, which is what we need to find, divided by the area at B. The area at B is 0.5. So solving for F will give you, F will be equal to F at B will be 2,000 divided by 0.5. So dividing this by 0.5 should give you 4,000. 4,000 newtons. If you divide 2,000 by 0.5, I think you should be able to get 4,000. Don't forget the units of force is the newtons. So that's what you are supposed to have done on this one. All right, so for today, we can stop here, and then we meet again in the next meeting, the next session, to look at the rest of the questions. Once again, my name is Mr. Paul Chilola, and remember to subscribe to this channel where learning is for free and you don't pay anything. All you have to do is subscribe to the channel and inform your friends to also join. My name once again is Mr. Chilola. Bye bye for now.